Ladies and gentlemen, welcome to SQL Server Performance Monitoring and Tuning video brought to you by SQLWorkshops.com. In this video, we will talk about Resource Governor. Resource Governor helps us limit the amount of CPU, memory, and the I/O resource available to users and applications. Until SQL Server 2014, the CPU limit was not working very well, but it works fine with SQL 2016. Let's look at some examples and then we will talk about memory and I/O throttling. To practice these examples along with me, you need the SQL test tool. To install SQL test tool, you can go to sqltest.org and click on the download link. There you will find a link to install SQL test. Once you have SQL test installed, you can click on File and you can click on Open Online Examples. There you will see an example called SQL Test Resource Governor CPU Setup. You can press OK to open this example, and we will go to Workload 1 and we will start this workload. So this workload will create 2 resource pools and 4 workload groups. Let's see how this is created. First of all, I will show you a picture of these 2 pools. So we got pool 1 and pool 2. In pool 1, we have 3 workload groups. P1G1 with high importance, P1G2 with medium importance, P1G3 with low importance, and P2G1, a workload group on the second pool with low importance. So here we are creating the database SQL workshops. We are creating a table tab 72, and then we are creating these 2 pools. Initially, I assign CPU % minimum and maximum to 0 to 100, and I create these 4 workload groups, the first 3 on pool 1 and the last one on pool 2, and I create all of them with medium importance. We will change it in a bit later. We are going to run 4 queries on these 4 workloads, and we want to run them from the SQL test tool. So to do that, what we have to do is connect each query to a particular workload group. Normally, in a customer implementation, you will assign users to a particular workload group based on username. But here we are going to use SQL test tool, and we are going to have single user to do all these queries. So what I am going to do is use the database name to assign them to a particular workload group. So what I am doing is creating 4 databases called P1, G1, G2, G3, and P2G1. And when the connection string has P1G1 as the database name, I assign them to P1G1 workload group. So this is our classifier function, and we created this resource pool and workload group. Now we will start our query. To start our query, we will open another instance of SQL test. And here we will click on File, Open Online Examples, and we will choose the Resource Governor CPU, not the setup. So we will open it, and here we see there are 4 workloads. All of them have the same queries. All of them connect to SQL Workshops database and execute this query in a loop. The reason I have wait for delay is to simulate user executing a query from the application. Execute a query, go back and execute a query. And to simulate this, I have this wait for delay in a loop. So to assign the first workload to the workload group P1G1, I will change here the database name to P1G1. We saw here, if the original database name is P1G1, they will go to group P1G1. This is the group we created, P1G1, on pool 1. So I will assign here P1G2. So here we P1G2. This workload will connect to the second workload group. Here we will have P1G3 and the last one P2G1. So So we will do P2 G1. So if you look here, I execute the first workload for 120 seconds in a loop, and the second workload will not execute at all because the number of iterations is 0 and the duration is not chosen. And also you see the same for workload 3 and 4. So if you look at the summary here, the workload 1 will execute for 120 seconds, workload 2, 3 and 4 will not execute. So if I do a start current, it will execute this query in a loop for 120 seconds. We can go to performance monitor to see the CPU used by these pools. So we will go to performance monitor and we will add the relevant counters. We will go to SQL Server resource pool stats. There is the resource pool stats. Here we will choose CPU usage on pool 1 and pool 2, and we will also add workload group stats. So we will add the CPU usage for pool 1, group 2, group 3 and pool 2, group 1. We will add these counters. So we have all of them here. And right now the pool 1 is executing a query. So that's why you see the CPU usage by this pool is 4%. In my computer, I have 24 CPUs. So if you execute the query on one CPU, I have max TOP1 here. So if you, the query itself is very simple. It's a simple seek query. So it probably uses one CPU. So that is the reason you see here one CPU is used. The CPU usage in my computer is around 5%. And here the pool 1 is using 4% of the CPU. Now let's cancel the query and we will start also the second workload, which is going to the other workload group but on the same pool. We will do a start all. Now you see both pools are executing, both workload groups are executing query. Now we go here, you see the CPU usage is 88% and 2 CPUs are in action. You see here 2 CPUs, around 10% instead of 5%. To study the resource governor CPU resource allocation, it's important that we assign this workload to the same CPU, all the workloads to the same CPU, so we see the importance and the throttling effect and so on. So what we are going to do is we are going here. First we will simply change the importance. I am now altering the resource pool, keeping the CPU percent the same, and I also let these pools use any CPU they want by setting affinity scheduler equal to auto, which means they can choose any CPU. I simply change I, medium and low. Before that we set it all of them to medium. Now I am setting it to I, medium and low. So when I do this configuration and I look at the CPU usage, the CPU usage hasn't changed, even though we have a query running on high importance in one workload group and the other one executing on medium importance. Both of them are using the same amount of CPU. So if you go to pool 1, group 1, it is using 4% of CPU, and pool 1 G2 is also using 4% of CPU, because here we don't limit them to use the same CPU. We say any workload group can use any CPU. Since I have 24 CPUs, each workload in this case, each query belonging to a different workload chooses different CPU, and there is no throttling. They are using all the resource available in that particular CPU. So now we will assign them to same CPU, and we see how the throttling mechanism works. So I go to workload group 2. Here I have I, medium and low, and I set the affinity of scheduler to 0, which means I say everybody use the scheduler 0, both pool 1 and pool 2. Let's start current. Let's go to the performance monitor. Looks like the workload is done. We will say start current. Now when you start current, start all to start workload 1 and workload 2. There you can see both workloads are running in pool 1, and pool 1 is using only 4% of CPU, that is 3.94% of CPU. If you look at the CPU usage of pool 2, it is 0 because we are not running any queries there. And if you look P1G1, it is using 2.9% of the CPU, and pool 1G2 is using 1%. In SQL Server, if the importance is I, it gets 9 slices of the CPU time. If the importance is medium, it will get 3 slices of CPU time, and the low will get 1 slice of CPU time. So what this means is we have here 4% of CPU. When you divide this 4% into 9 plus 3 slices, there you will see this guy is using, the P1G1 is using 9 slices, and this one is using 3 slices. That's why you get around 3% is used by pool 1G1, and around 1% is used by pool 1G2. That is the medium importance. Medium means 3 slices and low means 1 slice. Now we will include the other workload group, which is P1G3. That's the low importance. Let's include this. Let's start all. Now you see this query is running 200 milliseconds. This is running in 600 milliseconds, and this is running in 1.8 seconds. So the first one is running 3 times faster than the medium, and the medium is running 3 times faster than the low importance. This is how the importance mechanism works. So if you go to performance monitor and you click on the counter P1, you see it is still using around 4% of CPU. And if you go to P2, of course, there is no workload running there. And P1G1, you see 2.6%, and P1G2 should be 1/3 of this stuff. And if you look here, P1G3 should be around 300 something. So they are working according to this importance. So what we are going to do is start the 4th workload, which is going to the pool 2. So we will start. What happens now, SQL sees there are 4 queries running. It takes the CPU resource, that is 100%, and it divides among 4 queries. So it gives 75% of the CPU to pool 1 and 25% to pool 2. And within pool 1, the 75% of the CPU is shared across workload groups based on importance. So if we do a start all now, all workloads are running. You see 299 3 times is around 300, around 900, around 2.7, and this one is using 25% of the CPU alone. That's why it's able to get 600 milliseconds response time. So if you go here, you look at the usage, CPU usage, this is 2.8, is around 3%, and pool 2 will be around 1%, that is around 0.9899. So they divide the CPU based on the amount of queries that are running. And if you look at the P1G1, it is using around 2%, and this will be 1/3, that is 0.06, and this will be 0.6, and this is 0.2, and this is 0.9. So it uses all the CPU available, and within a group, within a pool, if there's only one group, then it doesn't matter whether it is a low importance, high or medium, because it takes all the CPU that is available for that pool and it shares if there are more than one low important queries running. Let's go to this example. So far everything is working fine. So if your manager asks, let's say, look, we have to have this report running 3 times faster than this report, you can say, let's do high importance, medium importance, or low importance as you like. Works perfect. On 2014 and 2016, it's not a problem. So now we will look at the issues that are related to CPU throttling with release 2000, SQL Server 2014 and earlier. Now what I am going to do is change this query to do a table scan. Our table, if you look here, our table has an index on column 1. So far we were doing primary key seek. we don't have an index on column 2. So when you execute C2 equal to something, it will do a table scan. That's what we are going to force here. So workload 4, that is going to the pool 2 workload group P1, P2G1. We are going to do a table scan. So we will do a start all. So look at this, no query seems to complete. If you go to performance monitor and look at pool 1, the pool 1 CPU is very low, 0.129%. Pool 2 took over all the CPU. The resource governor until 2014 doesn't work very well. It works for similar kind of workload. If everybody is doing seek or OLTP kind of queries, it works fine. But once there is a mix of workload, some table scans along with efficient seeks, then the table scan query takes over all the CPU, even though we allocate them on a different pool and give them a different importance. Let's go to Books Online on Resource Governor. There you see the benefits. Provide predictable performance. This is a benefit. Of course, you cannot provide predictable performance if you are going to mix workloads. And one of the constraints is Resource Governor can manage OLTP workloads, but that's what they mean. Once you mix them with a non-OLTP workload for SQL release 2014 and earlier, this doesn't work very well. This guy pretty much takes all the CPU available for SQL Server. What we will do now, we will go and change the CPU percent. Here we have CPU for pool to 0 to 100%. We will change this to 10% and see if this has an effect. We will do a start current and let's look at the statistics. It seems to have no effect. Little bit there was a dip, but not very much that is noticeable. So we'll go back here and change the CPU cap percent. They introduced this to further control the CPU usage. Let's do a start current and let's look if the CPU, the workload seems to have completed. We will start all. The workload is running again. We will go back here. Not much difference. It is 3.8. Now what we will do is we will go back to here and instead of 10%, we will change it to 1%. Of course, this is the least possible. We will start current and we will go to performance monitor and we look here. The CPU usage seems to be dropped a little bit. It is 2.2, but still higher than pool 1. So this cap works to some extent. So when you have mixed type of workload, this resource governor CPU throttling doesn't work. Let's cancel the query. We will put it into C1. So everybody is now using the efficient mechanism. Let's go to here, performance monitor. There you see now it is actually using 1%. So that's why the CPU usage by this pool is very low. What we will do is we will put back what we had before. That's 100%, start current, and immediately you will see this pool gets its share of CPU, that is 1%, like we saw before. But what we are going to do is we are going to change the query where the importance is low. So query cancel, and we are going to change where the importance is low on pool 1. So we are going to pool 1, and where the importance is low, we are going to change the query to do a scan. We will start all. Now we will look at performance monitor. There you see pool 1 took over all the CPU. Pool 2 doesn't get any CPU because the inefficient query is running on pool 1. And if you go to pool 1 group 1, it doesn't seem to have any CPU usage, very little, because this is an efficient query. This is also an efficient query. The inefficient query is on workload group pool 1 G3, and there you see it pretty much took 3.6% of CPU. So when you have mixed workload, it is you cannot use resource governor for CPU throttling, that is with the min percent and max percent. This is not a problem in SQL 2016. Let's execute the same query in SQL 2016. First, we will prepare the workload. I have here the SQL 2016 RC1. I have all the counters selected. We will go here. I want to execute this on SQL 2016 instance. So what I am going to do is go to settings, general settings. Here I am going to say wherever there is local, substitute that with SQL 2016 RC1. This is the name of my instance. I say click in the connection string. So connection string can do a search and replace. So all of them will be replaced with SQL 2016 RC1. So there we will create this resource pool and group. Okay, now we will set this scheduler affinity, and also we will leave this percent to 0 to 100 to 100. CPU cap percent, min percent, both of them we will leave it as 100, and we will leave the importance high, medium and low like we have before. We will do a start current, and now we will go here. We will have C1 equal to 10. All queries are efficient. We will start all workloads. Here also we have to change the connection string. So we will go to general settings. We will have local equal to this one. We will enable this and we will start all, and we will go to SQL 2016 and monitor the performance. In this computer I have 8 CPUs, so that's why you see around 9% CPU usage. So 9% CPU usage on pool 1, 3% on pool 2, that is 12.5. You know, when you have 8 CPUs, one CPU is like 12.5%. I again limit one CPU for all the pools here. And you see here, this is 6% to 2% and less than a percent. And here it is 3%. It works perfect. Now what we will do is we'll do query cancel and we will change this query. We will change this query to C2 equal to 10. That is the inefficient version. And when you go here, here in the other instance, you see the CPU usage remains the same. It is not affected by this inefficient query. So this problem is addressed in SQL 2016. So before you promise your manager that you can use resource governor to allocate different CPU resource based on importance, you have to realize this doesn't work well when you have mixed kind of workload for releases SQL Server 2014 and earlier. But the interesting thing is, if let's uncheck this connection string search and replace, if all queries are inefficient, that is not a mixed kind of workload, all queries are inefficient, then the resource governor mechanism will work fine. Let's do start all. Now it's going against our local server. You see the other instance is idle. So if you go to the local server, P1 is using 3%, P2 is using 1%, and here 2.7 and 0.2, and this thing works perfect. Resource governor doesn't work very well for CPU throttling, that is to set maximum and minimum CPU percent for releases SQL Server 2014 and earlier. It is not a problem in SQL Server 2016 where you can set the importance and you can have mixed workload and things work very well. Resource governor in general works fine for setting processor affinity. If you want to set a pool to use certain CPUs or certain NUMA nodes, this works perfect. It works perfect for setting max DOP to control the amount of CPUs a single query can use. When it comes to memory, you have to be careful when you set the max minimum memory to throttle the memory usage, because this can easily lead to performance issues. I cover these things detailed in my workshop. Also, when it comes to setting maximum memory grant for a particular pool, there are some cases where this is very useful, the performance is much better, and there are some scenarios where this can lead to concurrency and performance problem. The memory throttling is very useful to bind in-memory OLTP databases. This also works fine. When it comes to I/O, there is an implementation issue that could affect the overall performance of the server. For example, you could define I/O throttling for certain set of users, but the other set of users, like your manager, might complain, look, today my query was executing slow. What did you do? Are you limiting my I/Os? You might tell him, well, I don't limit your I/Os, but there is an implementation issue that can lead to such problems. If you are interested in attending one of my workshops, you can go to this website to check more information, sqlworkshops.com. You can click on workshops. There you will see the SQL Server performance monitoring and tuning workshop. You can click here for agenda. If you have any suggestions or comments, please feel free to contact me. Thanks for listening. Bye.